Hello friends, welcome today's lecture Shear Force and Bending Moment. Myself Mr. Y.S. Patil, Department of Civil Engineering, Sharad Institute of Technology, College of Engineering, Yadrao. In this lecture, we studied about shear force and bending moment diagram for cantilever beam. So, cantilever beam means at one end fixed, other end free. Subject in this problem, this is the ABCD is a cantilever beam supported at A and at point C, D and B acting a point load. So before draw the SFD and BMD, as usual you should calculate first reactions. At fixed end there are three reactions, that is first one is a vertical, second horizontal and third moment. So in this beam is only subjected to vertical forces. There is no horizontal force, means just you got only RAV and MA. There is no horizontal forces, so reaction at A in horizontal direction there will be 0. So you not need to calculate that horizontal reaction. So only calculate vertical reaction. In this beam only support is single support, that is total load carried by only this A support, that is a fixed support. So RA is equal to summation Fy is equal to 0, upward force is equal to downward forces. So once again number of upward forces is now 1, that is only Ra, and number of downward forces is 3, that is 20, 20 and 10. So total downward force is 50 kilonewton and upward is Ra. So reaction Ra is equal to 50 kilonewton. So this is the simple method or simple way to calculate reactions Ra. Then next calculate shear force. As usual, first of all mark sign conventions. Upward force right side negative, downward force positive. So each and every point having two shear force values. So calculate once again, mark a section just right side of B and consider right side of B, that is BR is equal to 0 because there is no force on the right side of the section. Then next mark section at just left of B. This is a section left of B and consider right side. So number of forces on the right side of the section is 1, that is 10 kilonewton, and the direction of the 10 kilonewton force is downward. So downward force is positive. So this is the BL. Then next goes to the point D, mark a section on the right side of the D and just right and consider right side of the section. So number of forces on the right side of the section is 1, that is 10 kilonewton and direction is downward, so consider positive. Then next mark a section on the just left of D and consider right side of this section. So number of forces acting on the right side is now 2, that is 10 kilonewton and 20 kilonewton, and both forces are going towards downward direction. So both consider as a positive. So 10 plus 20 is equal to 30 kilonewton. Similarly, moves towards point C and mark a section at just right of C and consider right side of this section. Then number of forces on the right side of the section is 2, that is 20 and 10, as good as that DL. So CR value means shear force at CR is unchanged, that is 30 kilonewton. Then next mark a section on the left side of the C and consider right side of the section. Whatever section mark right or left, always consider right side of the section. So number of forces now 1, 2, 3, that is 10, 20, 20. So 10, 20, 20 is equal to 50 kilonewton. Then next moves towards A point. Mark a section just right of A and consider right side of the section. So total number of forces is 3, and that is 10, 20, 20. All 3 forces are going in a downward direction, so all forces are considered positive. So answer will be 50. Now consider left side of A. So total number of forces, now this is the RA, and the RA value will be 50 and going in the upward direction. So total number of forces 1, 2, 3 and 4. Out of these 4 forces, 3 forces are going in a downward direction, 1 force going in a upward direction. So downward direction total number of forces 20, 20, 10, that is 50 kilonewton, and upward force is 50 kilonewton. So plus 50 minus 50, it becomes 0. So start with 0, end with 0. By using this shear force value, we should draw SF diagram. So at BR 0, BL 10, DR 10, DL 30, CL CR 30, CL 50, AR 50 and AL 0. All for all points join with straight line. In between B to D there is no load, so it will be horizontal. At point D there is a vertical load, so it is a vertical. At point means there is between C to D there is no load, so it is horizontal. At point C there is a vertical point load, so it is a change vertically. In between A to C there is no load, so it is horizontal. And at point A there is a vertical reaction, so it is changed vertically. And this is the SFD for cantilever beam. Then next, bending moment calculations. So once again, bending moment at B is equal to 0 because that B is free end. So assume sign conventions, right side anti-clockwise positive, clockwise negative. So bending moment at B is equal to 0. Then next, bending moment at D. So mark a section at point D, exact on point D, and consider right side. So number of force on the right side is 1, that is 10 into perpendicular distance is 1.5, and direction of the moment with respect to D point is clockwise, and clockwise moment is minus. So minus 10 into 1.5, that is minus 15 kilonewton meter. Then next, bending moment at C. So mark a section at point C and consider right side. Number of forces now 2, that is 10 and 20, and both forces are generate a clockwise moment with respect to C. So both moments consider minus. So minus 10 into perpendicular distance from C to B is 2.5, and minus 20 into 1, that is minus 45 kilonewton meter. Then moves towards point A. Consider now right side. Number of forces on the right side is 3. So 10 into perpendicular distance 1 plus 1 plus 1.5, that is 3.5, minus 10 into 3.5. Then 20 into 1 plus 1, 2. That is 20 into 2, and it will be minus. Then this 20 into 1, that is minus 20 into 1. Means bending moment at A is equal to minus 95 kilonewton. This is a minus 95 kilonewton meter. So by using this coordinate, draw BM diagram. All bending moment values are negative, means all values plotted below the baseline of this, below the baseline. So first bending moment at B 0, at D minus 15, means this is the 15, minus sign you should not mention because already plotted bottom of this baseline. Then this is the 45 and this is the 95. All points join by using straight line, inclined straight line, because there are no UDL, so you should draw inclined straight line, and whole BM diagram is negative 1. So this is the BMD for cantilever beam. Then next we see one more problem, a cantilever beam subjected to UDL and point load. So first, once again we calculate reactions at in this beam D to C. It is a UDL having intensity 4 kilonewton per meter and length of this CD span is 2 meter. At point B 20 kilonewton point load, at point A 10 kilonewton point load. So first calculate RD. Once again in this cantilever beam only one upward force, that is RD, and three downward forces, that is UDL 20 kilonewton and 10 kilonewton. So RD is equal to, this is upward force is equal to downward forces. Downward forces are first one UDL, that is 4 into 2 plus 20 plus 10. So RD becomes 38 kilonewton. RD is equal to 38 kilonewton. Then next we calculate shear force. So once again first assume sign conventions, right side upward force minus downward force plus. At AR, mark a section at A right side, no forces on the right side of the section, so it becomes 0. Then AL, number of forces 1, that is 10 kilonewton going in a downward direction. Downward direction will be plus, so plus 10 kilonewton. Then BR, number of forces on the right side is 1, that is 10 kilonewton downward direction, so it becomes plus 10 kilonewton. Then BL, number of force on the right side of the section is now 2, that is 10 and 20. Both forces are going in a downward direction, so it will be positive. So 10 plus 20 is equal to plus 30. Then CR, so number of forces is equal to 2 forces, that is 10 and 20. So CR becomes 30 kilonewton. CL, there is no any point load or any load at point C. So it is a C point is the end point of the UDL. So there is a no load on the C point. So it become equal to that CR value, that is CL is equal to 10 plus 20 is equal to 30 kilonewton. Then move towards DR, mark a section on the just right of D and consider right side of the section. So total number of the forces on the right side of the section at DR is 3 forces, that is 10, 20 and UDL. So 10 plus 20 and UDL is 4, intensity of the UDL is 4 and length of UDL is 2. All 3 forces are going in a downward direction. So all 3 forces will be considered positive. So 10 plus 20 plus 8 is equal to 38 kilonewton. Next DL, mark a section on the left side of the D and consider right side. So 38 kilonewton downward force, and we know the RD value, that RD is equal to 38. So minus plus 38 and minus 38 become 0. Means start with 0, end with 0. By using these coordinates or that these shear force values, you should draw SF diagram. Means 0 at AL 10, BR 10, BL 30, then CR and CL 30 and AR 38 and DR 38 and DL 0. So in between A to B there is a no load in the span, should be horizontal. At point A there is a vertical load, so it changes vertically. At point B there is a vertical point load, so it changes vertically. In between B to C there is a no load, so it should be horizontal. Now see, at point C to D there is a UDL. So if UDL having on the beam, the SF diagram is inclined straight line, means that from C point to D point it should be inclined straight line. And this is the SF diagram. All values are positive, so SF diagram will be positive diagram. Then next BM diagram or BMD for cantilever beam. Bending moment, first of all sign conventions, consider right side, anti-clockwise moment positive, clockwise moment negative. So bending moment at A is equal to 0 because that is a free end. Then next bending moment at B, mark a section at point B. Number of forces on the right side is now 1, that is 10 kilonewton. With respect to B, that 10 kilonewton force generate a moment and the direction will be clockwise, and clockwise moment is minus. Perpendicular distance from point B is 2. So minus 10 into 2, that is minus 20 kilonewton meter. Then next at point C, bending moment at point C. So mark a section at point C, consider right side. The number of forces on the right side now 2, that is 10 and 20. both forces with respect to C, the direction of the moment is clockwise. So both forces consider minus. So first 10 kilonewton, this is the force, and perpendicular distance from point C is 1 plus 2, that is 3, that is 10 into 3, and it should be minus because the direction of the moment is clockwise. Then next 20 kilonewton, this is the force 20 into perpendicular distance from point C is 1 meter. So minus 20 into 1. So the bending moment at C is equal to minus 50 kilonewton meter. Then next bending moment at D. Consider right side. Number of forces now 3, that is 10, 20 and UDL. So first, and all three forces generate a moment with respect to D is clockwise, and right side clockwise is minus. So all moments will be considered negative. First 10 kilonewton force into distance from point D is 2 plus 1 plus 2, that is 5, means minus 10 into 5. Then next 20 kilonewton, this is the force 20 into perpendicular distance from point D is 2 plus 1, that is 3, means 20 into 3. Then next UDL, intensity of the UDL is now 4, this is the 4 into length of UDL is 2, so this is the 2, and where it is at half of this span, that is CD, means 2 by 2. So final answer, bending moment at D is equal to 118 kilonewton meter, and this will be minus, means all values, BM values will be minus. By using these BM values, now we draw BM diagram. So starting with A point, bending moment at A 0, bending moment at B minus 20. So minus value you should plot below the baseline, that is 20. Bending moment at C minus 50. So from C point it will be 50. Then bending moment at D is minus 118 kilonewton meter. Now draw in between A to B, it should be inclined straight line because there is no load. BA. Then in between B to C, there also no load. So should you draw inclined straight line, means this is the inclined straight line up to BC portion. And from C to D, there are UDL on the beam. So where are the UDL on the beam? Your BM diagram should be parabolic. This curve is a parabolic one. Means A to B inclined straight line, B to C inclined straight line, and C to D is a parabolic curve. And all values are negative 1. So your BM diagram is totally negative. This is the final BMD of this particular beam. Thank you.